Hi everybody, my name is Attila Toth. I'm a developer advocate at ScyllaDB, and in today's video I'm going to show you a ScyllaDB Vector Search sample application, a movie recommendation application. I will show you how it works and how you can implement a vector search with ScyllaDB. So let's get started. The application is fairly simple. You just input what kind of movie you want to watch. So in this case I added sports, and then the first result is going to be the best match. So this is comparing the plots of the movies. So we are comparing the plot of this movie to the input text, and this is the best match. And this is using ScyllaDB Vector Search under the hood. And then below we have more recommendations that are also similar to the input text, but not as similar as the best match. You can find the source code on GitHub, as well as detailed instructions how to get the app up and running. If you're interested in a step-by-step tutorial that builds the app from scratch, you can also find that in the documentation. I will put links in the description. All right, so let's look at the code. So I'm going to open VS Code. Let's start with the requirements. So if you look at the requirements, we have just a few Python packages that we use. First of all, the ScyllaDB driver, because we are working with ScyllaDB, so you will need the ScyllaDB Python driver. Then we have sentence transformers, which is needed in order to create the embeddings, because we don't want to use any OpenAI API keys or other paid services. This is just a simple demo, so you should be able to run it on your computer without any additional hurdles like getting API keys. Then we have a Streamlit, which is, as I said, the UI for the application. And we also have PyIdentic as a requirement, just to make it easier to work with objects after querying data from ScyllaDB. Going further, the application has a config.py file, which includes the ScyllaDB Cloud credentials. So you can find the host address as well as other credentials needed to connect to ScyllaDB. Now, when it comes to ScyllaDB, we also have a ScyllaDB Python module just to make it easier to query data from our vector search application. So we have this Scylla client class, which handles creating the connection, creating the session, inserting data, and querying data. So these are just helper functions to help us work with ScyllaDB. The next thing I want to highlight is the schema. So we have a schema.cql file, which actually gets executed when you run the migration script at the beginning of the project. So what this includes is the key space creation CQL. So we will create a key space called recommend with a replication factor of 3. Then we have the create table definition, and we have a few columns here to store information about the movies, things like release date, title, genre, things like that. What I want to highlight is the plot. So we are storing the plot of the movies, and that is the data point that we are going to use for vector search. So we not just have a plot column, we also have a plot embedding column, which is the embedding version of the plot. And as you can see, we are using the vector data type, and we have the dimensions defined as 384, because that is the number of dimensions that the sentence transformers model that we are using produces. And then finally, the primary key will be ID as the partitioning key. So this table also allows us to query each movie by the ID very efficiently. The other two things I want to highlight is, first of all, CDC. We are enabling CDC because that is needed for ScyllaDB to use vector search. And then the last thing is the index. So this is very important. We are creating a vector search index using the plot embedding column, and this is going to enable very efficient vector search on this column. And as you can see by the name of the index, this is going to be an approximate nearest neighbor, an ANN index. So if you want to work with vector data, you want to build vector search application with ScyllaDB, make sure that you are using the vector data type with the proper number of dimensions according to your embedding model. Make sure to enable CDC and make sure to use the vector index to create an index on the vector column. So with that, we covered the database implementation side of things. Now let's look at the application itself. First, let's look at the models file. So as I mentioned before, we are using Pydantic. And so basically, right after we are querying data from ScyllaDB, we are using these movie objects to handle the data in Python. To make things easy and modular, we also have a separate module to create the embeddings. So we have an embedding creator class with a function to create the embeddings using sentence transformer. So you can just provide any text input for this function, and it will use the embedding model to return a list of float values that can be inserted straight into ScyllaDB. All right, now let's actually see how we run vector search queries with ScyllaDB. So let me open this module called Recommender. This is the module that handles the recommendation itself. It finds similar movies. And as you can see, this is where we have the select statement. So if you look at the select statement, we're not doing anything crazy. We are selecting all the columns, which is okay for us because we don't have a lot of columns. And we are ordering by the plot embedding and using the ANN off operator. So this is where vector search is getting executed. We are using the approximate nearest neighbor index, and we are also limiting the number of results, which is a requirement if you want to use the vector search function. So this will return by default 5 similar results to the user input. Another thing to notice here is that we are not just providing the user input as is, because obviously that also needs to be a vector. So we are using the create embedding function to turn the user query into an embedding, so we can compare embedding to embedding. And then finally, we are querying the results and turning the results into movie Pydantic objects, so we can easily work with it in Python. And then finally, on top of all this, we have a Streamlit UI in the app.py file, which uses all these modules. So as you can see, we have this display search results function, which executes the similar movies function that I just showed you before, takes the user query, turns it into an embedding, does the vector search, and then returns the results of vector search. All right, so that's it. That's our application. Everything is on GitHub. You can find the source code on GitHub. The repo has a short README that allows you to run the project yourself after cloning the repository. If you're interested in a step-by-step tutorial which builds the app from scratch, that's also available. I will put the link in the description. It's in our documentation. If you want to build the app yourself, you can follow the instructions here as well. So that's it. I hope it was useful, and I see you in the next video. Bye.